24, question 1. Write the following in order of size, starting with the smallest: cos 90, cos 100 and cos 300. A good knowledge of the y equals cos x curve is required here. So our key points are 0 degrees, 90 degrees, 180 degrees, 270 degrees and 360. Curve goes up to 1 and down to -1. Cos 90, as you can see, lies on the x-axis, so that's got a value of 0. Cos 100 is just slightly beyond. Now we don't know exactly what its value is, but it's definitely got a negative value which is below a value of 0. Cos 300 lies 30 degrees beyond 270 out there. We don't know exactly what the value is, but we can say that it's definitely positive. So we're listing these in order from smallest to highest. Well, the smallest value is definitely this one, and that's cos 100. The next smallest is cos 90. And then the highest value is given by cos 300. And that's the final answer. For question 2, f of x equals 3 sin x. Find f of 270. Well, this is just a straightforward substitution question. So f of x is 3 sin x, so f of 270 is just 3 sin 270. Enter that into the calculator and you'll get -3. Part B, f of t equals 0.6. Find two possible values of t. Well, f of x is 3 sin x. F of t, then, it makes sense, would be 3 sin t. And if the question had, for that matter, said 3 sin a, f of a rather, that would be 3 sin a, f of g, 3 sin g. Now, the question then tells me that f of t is equal to 0.6, so what I can do then is make 3 sin t equal to 0.6. This is now developing into a trig equation question, and a pretty simple one. So I'm going to bring the 3 down and divide, and I'll get sin t is equal to 0.6 divided by 3, and that sin t is equal to 0.2. At this point I'm thinking about putting down my cast diagram. I'm in the O quadrant and the sine quadrant, and I'm going to enter this information into the calculator. And that will give me 11.5 degrees from the O quadrant. For the sine quadrant, my thinking is to take that solution and subtract it from 180 degrees as indicated by that line. So 11.5 off of 180 will give me 168.5 degrees, and that's the final answer to the question. Section 24, question 3. The diagram shows part of the graph of y equals tan x. The line y equals 5 is drawn and intersects the graph y equals tan x at P and Q. So we're looking for the intersection of the curve and the line, so points at which they're equal. So what I can say there is y equals 5 at the points intersection is equal to y equals tan x. So it's not too much of a stretch at that point to create a trig equation. Tan x is equal to 5. I'm going to put down the cast diagram, and I'll be in the O quadrant and the tan quadrant. So x equals tan inverse 5, and enter that information into the calculator. and that should give you 78.7 degrees to 1 decimal place. In the tan quadrant, our thinking is to move on from 180 degrees, and I'm going to be moving on by 78.7 degrees, so that will be 258.7 degrees. Now if I have a wee look at the question says find the x coordinates of p and q. Well, we can see that the x coordinate of p then is going to be the 78.7, and the x coordinate of q is going to be 258.7. Now what we can see is also that the tan curve repeats itself after 180 degrees. Part B says write down the x coordinate of the point R where the line intersects again. So if we've got this one, which we do 78.7, and this one, which was 180 degrees on from that, 258.7, I think it's safe to say that we move on 180 degrees again, and that will give us the x coordinate of R. So that's going to be 258.7 plus 180, and that will give me 438.7 degrees, and that's the final answer to the question. Section 24, question 5. Solve algebraically the equation 5 cos x plus 4 is equal to 0. Well, I'm going to first of all move the 4 across and make it minus 4, and then I've got cos x is equal to minus 4 over 5. Now, with that question, depending on your teacher's exact instructions, the wording may differ, but you know with that one that when it's negative you make the trig equation positive, and instead of looking in all in cos as you would normally do, you now look in sine and tan. So x equals cos inverse 4 over 5. Then enter that into the calculator. And that will give you 36.9 degrees. Now you're careful at that point because you're not looking in the null quadrant, so that's not actually a solution. You're looking in the sine quadrant, and remember in the sine quadrant it's 180, take away your answer, and you're looking in the tan quadrant because that's the other one we've ticked, and that's 180 plus your answer. So 180 take away 36.9 is 143.1 degrees. That's my sine quadrant solution. Tan quadrant solution is 180 plus 36.9, and that's 216.9 degrees. And that's the final answer to the question.